Hello everyone, welcome to another video in Theory of Structure. By the way, to those who are new in my channel, I am Engineer J. Cabuñas. I am a civil engineer, and if you are new to my channel, please don't forget to subscribe and hit the notification bell. And in this video, we will learn how to determine the determinacy and stability of structure. Okay, so this is one of the fundamental topic in theory of structure. But before that, let's try to discuss some important terms that we will be needing in the future. So we have different type of forces. We have external force and internal force. When we say external force, these are applied forces and reaction forces. Like for example, if we have this beam, this is an example of a simply supported beam. So applied forces, these are concentrated load or a uniformly distributed load or a linearly varying load like a trapezoidal or a triangular load. And external forces can also be reaction. Okay, if we have hinge support, so we know that we have two reactions. We have reactions along the y-axis and reaction along the x-axis. Now, for rulers of port, we know that we have only one reaction, and that is vertical reaction. Okay, but if we have a fixed support, let's say we have this one, we know that on the fixed support, we have three reaction forces. These are vertical, horizontal, and moment reaction. Okay, so these are considered as external forces. Now, internal forces, these are forces and couples exerted on a member or portion of the structure by the rest of the structure. So these are forces exerted by a structure to another structure. And one example of that is that when we cut our beam, let's say when we cut our beam at this point, so we would have a internal forces shown. We would have, let's say that is the cut section. So on the cut section, we would have a vertical internal force, a horizontal internal force, and a moment internal or an internal moment. Okay, so those are internal forces. We also have internal hinges and internal ruler. So let's say you have this beam. So internal hinges is when we have an internal hinge within or at any point within the beam. Okay, so if we cut this beam, we would have a vertical force and horizontal force. Since that is hinge, we do not have moment at this point. So we do not have moment or internal moment. Okay, so on the other side, we would have also a equal in magnitude force but opposite in direction. So since on the right member we have a downward force, so therefore on the right member we would have a upward force and a rightward force. So these are equal in magnitude but opposite in direction. So these are internal hinges. But we also have internal ruler. So let's say we have this beam, we have ruler. So this is an internal ruler wherein at this point we only have one internal force, and that can be either upward or downward internal force. Okay, so those are what we call internal forces. We have internal hinge, internal ruler, and a internal forces with moment if we cut at any point within our beam. Okay, so those are the type of forces that we will be dealing in this course. Now we also have internal stability. Now, a structure is considered to be internally stable. When we say internally stable, that is rigid if it maintains its shape and remains a rigid body when detached from the support. Let's say if we have a support here, hinge, we know that if we have a support, there would be no deflections, okay, or there would be no movement in our structure. So if we detached or if we eliminate the support, our structure would still have the same stability, okay, or our structure would have the same shape, and that we know that this one is rigid. Okay, so the same as with this one, the shape will still remain even if it has a support or even it has no supports. Okay, so it would remain its shape. Thus, it will remain rigid with or without support. So we can say then that a structure is internally stable if it maintains its shape and remains a rigid body even if it has no support. Okay, so there would be no deflections or movement even the support is detached from the structure. Now, in contrary to that, we have also a structure is considered to be internally unstable or non-rigid if it cannot maintain its shape and may undergo large displacement when not supported externally. So just like this one here, if we do not have support at point A and point C, there would be a possibility that leg C would have a deflection. So this usually happens when we have internal hinges. Okay? Just like this one here. So if we have internal hinges at point B, so there would be a possibility that leg BC would have a large displacement, or it would move, or possibly it would have a rotation. So the same as with this frame B, we have internal hinge at B. So if we omit the support at point A and point C, so there would be a possibility that leg BC would also have a rotations, and the same as with this truss here. Okay, so it's important that we must refrain from designing an internally unstable structure in actual practice. But if that happens, we need to provide enough supports in our structure, and that to prevent any movement or that would act against any motion in our structure. Okay, that's the important, or that is the use why we need to have a sufficient support in our structure if we are having an internally unstable structure. Okay, so that is the two type of internal stability. Again, we have internally stable and internally unstable structure. Now, we also have the determinacy of internally stable. So, we can say that structure is statically determinate. Statically means there would be no motion. So, therefore, our beam should be at rest. Okay? So, we can say that our structure is determinate when the unknown forces can be computed using equilibrium equation. So, if the equation condition such as summation of forces along the x is equal to 0, summation of force along the y is equal to 0, and summation of all the moment equals to 0. So these three equations are very important in determining unknown. Okay? So if these equations are enough to compute or to determine the unknown, so therefore we can say that our structure is statically determinate. But if in the case that these equations are not adequate enough to compute for unknown forces, that means we have a statically indeterminate structure. Again, statically indeterminate structure is when the number of unknown forces is more than the equilibrium equations. Okay? So these are how we determine whether our structure is determinate or indeterminate. In order to identify the determinacy of a internally stable structure, we have this condition. If R is lesser than 3, where R here is the number of reactions, and 3 here is the number of equilibrium equations. Again, we have 3 equilibrium equation, summation of forces vertical, Okay, summation of forces horizontal is equal to 0. And summation of moment is equal to 0. So, we have three equilibrium equations. Okay? So, if our reaction is lesser than 3, then the structure is statically unstable externally. Okay? If our number of reaction is equal to 3, therefore, the structure is statically determinate externally. If the number of reaction is greater than 3, therefore, our structure is statically indeterminate externally. So, this is for internally stable structure. But what if we have an internally unstable structure? So, if that includes internal hinges or internal ruler in our member. Okay? So, we have just need to follow this formula where R plus Fi. R here is still the number of reactions. Fi here is the number of internal forces. So if we have internal hinges or internal hinge, the number of forces is equal to 2. But if we have an internal ruler, from what I have discussed earlier, the number of internal forces is equal to 1. Okay? And 3, where this is the number of equations or equilibrium equations, then NR here, this is the number of rigid member, okay, or the number of a member in the beam. And if R plus Fi is lesser than 3n, then we can say that the structure is statically unstable externally. If this is equal, then our structure is statically determinate externally. But if it is greater, then the structure is statically indeterminate externally. So that's how we determine or how we compute for the determinacy of internally stable and internally unstable structure. Okay, so now let's try to solve problem. Okay, so we identify if the given structures are statically determinate or statically indeterminate, and we also need to know the stability of these structures. Okay, so we have this first problem. Let's say that's our letter A. So in this case, we do not have internal hinges within the beam, correct? So therefore, if we detach or if we omit the support, so that would remain its shape, and that is a horizontal beam. Since again, we do not have internal hinges, so it would maintain its shape. So that means this one is an example of internally stable structure. Okay? So, since that is internally stable structure, then we have to determine the number of reactions. Now, again, this is a hinged and a ruler. Okay? So, if we try to draw the free body diagram, we would have this one. So, at this point, at the hinge support, we have two reactions. Let's say that's our R, Y, and Rx. And at the ruler support, we have only one reaction, and that is vertical reaction. Let's say that's our Ry. So in this case, the number of reaction is 3, correct? And since we know that when R is equal to 3, that means this one is a statically determinate externally. Okay? So this is the answer for our first figure. Okay, so therefore this one is a determinate beam. So we can actually compute for the reactions by just using the equilibrium equations. Okay, now let's try to determine the determinacy of our figure B. So in this case, we have a fixed support, and we also have here, we have a ruler support, and this one is a ruler support. Now, you can pause this video if you want to answer it on your own, okay? So just give yourself 1 minute to determine the determinacy of the structure. You can pause the video. Okay, so let's try to draw the free body diagram. So on the fixed support, we have 3 reactions. Okay, we have vertical, horizontal reactions, and since that is a fixed support, therefore we have a moment reactions. Okay, now at the ruler support, we have only 1 reaction, and that is a vertical reaction. Okay, so therefore we can count the number of reactions here. We have 1, 2, 3, 4, 5. So we have 5 reactions. So we have R is greater than 3. So that means we have a statically indeterminate externally. So this is the determinacy for our figure B. And for its stability, now take note, we do not have internal hinges within the beam, so therefore this one is internally stable. Now we need to determine the degree of indeterminacy. Now take note, our reactions here are 5, correct? And that is 2 more than the number of equilibrium equation. So therefore, the degree of indeterminacy is equal to 5 minus 3, and that is 2. That is our degree of indeterminacy, or our beam is indeterminate to the 2nd degree. Okay? Now, how about figure C? Okay, so this is a restrained beam. This one is fixed support, and this one is fixed support as well. Now, take note, we have internal hinges. Okay, we have 2 internal hinges within the beam. So, if we try to draw the free body diagram, we would have this one. So, at the fixed support, we have force vertical, horizontal, and moment. Okay. Now, at the point of internal hinge, so we have here 2 internal force, and that is we have a vertical force. Let's say that's going downward, horizontal force. Okay, so we have 2 forces. Now, for the middle member, okay, so we still have, since that is in opposite in directions, we have upward and support rightward. And at this point, we have downward and leftward support. Now, for the last member, or the leftmost member, so we have opposite in directions. Okay. And on the fixed support, we have upward, horizontal force, and a moment support. Okay, so if we try to count the number of reactions, so on the left support, we have 3 reactions. Okay, now on the internal hinged, we have 2 reactions. Okay, we count this as 2. Okay, because that is on the same magnitude. Now on internal hinge, we have still another internal hinge here. We have 2 reactions or internal forces. And on the fixed support, we have 3. Okay? Now, we have the formula R plus Fi, and we have 3NR. So, the number of reactions here, since we have 2 supports, so we have 6 reactions. Okay? 3 from the left support and 3 from the right support, plus the internal forces. So we have 2 internal hinges, and then each internal hinge has 2 internal forces. So we have 2 plus 2, we have 4 internal forces overall. Okay, so we have 6 plus 4, that is we have 10. Then we have 3 times the number of rigid member. So we have 1 first rigid member, we have second rigid member and the last rigid member here. So overall, we have 3 rigid members. Okay, so we have 3. So that would give us 3 times 3, 9. Okay, so therefore we have greater than, correct? So we have 10 greater than 9. So that means we have a statically indeterminate externally. Okay? And the degree of indeterminacy is equivalent to, now we have 10 minus 9 is equal to 1. So therefore, our structure is indeterminate to the first degree. Okay? Now for stability, since we have internal hinges and if we omit the external support, then there would be a rotations of the member, okay, or there would be a large deformation due to internal hinges. So that means this one is an example of an internally unstable structure. Okay, and that is our first 3 example. Now let's try to solve an example of frames. Okay, so we have this first member here. Now if we try to omit the external support, okay, this one, so there would be a large deformation, or there would be a change in shape. So that means we have an internally unstable structure. And this large deformation here is due to internal hinges. Okay, so if we omit this fixed support here, so there would be a possibility that this leg would have a rotation. Okay, so there would be a large deformation or or angle of rotation. So now let's try to determine if it is a determinate, indeterminate, or unstable structure. So if we draw the free body diagram, we would have at this hinge support, we have 2 reactions, okay? And that reaction there is perpendicular to the surface, this one, and parallel to the surface as well. Now at the internal hinge at this point, we have 2 supports or 2 internal forces. Okay, the same as with the horizontal member. And for the vertical leg on the right side of the structure, we have internal hinge as well. We have downward and leftward. Okay, again, our forces at that point are equal in magnitude but opposite in direction. Now on the lower end, we have a fixed support, so therefore we have a vertical reactions, horizontal reactions, and a moment reaction. Okay, so from the formula, R plus Fi 3NR, so we have number of reactions here. Now at the hinge we have 2, and on the fixed support we have 3. Okay, we have the vertical, horizontal, and moment. So overall we have 5 reactions, then plus the internal force. The number of internal forces, we have 2, since we have internal hinged, and on the other internal hinge we have also 2 forces. So overall we have 4 internal forces. Okay, so we have 9. Now we have the number of rigid members. So we have this one as well, and this one. So we have 3 rigid members. So we have 3 times 3, and this equals to 9. That means we have equal sign in between. So that means since we have equal sign, so this one is a statically determinate externally. Okay? So we can actually use the equilibrium equations by or in solving the unknown forces. How about this one here? So we have the number of reactions. So at this point we have, since this one is fixed support, we have 3, correct? And this is a hinge support, then we have 2. And this one is a fixed support, then we have 3. So the number of reactions are 8. Okay? Plus the internal forces, we have 2 at this point, since that is an internal hinge. Okay, so we have 2. Then we have 3 times the number of rigid member. So we have 1. And this, so we can count these 3 members here as a whole, since we do not have internal hinged within this member here. Okay, so we have overall we have 2 rigid members. Again, we can count these 3 members here as one whole rigid member. Okay, so overall we have 2 rigid member. So we have 10. At this point we have 6. So that means we have a greater than sign. So we can say that this one is a statically indeterminate externally. So we cannot use the equilibrium equations in computing the reactions. How about the last one? So you can pause the video, okay, and try to answer our last figure here. Okay, so let's try to draw the free body diagram, but first let's try to determine its stability. Now take note, we have internal hinge, and if we try to detach it from the support, then this leg here would deform freely, okay, if we do not have support. So that means this one is an example of internally unstable structure. Okay? Okay, now let's try to draw the free body diagram. So at this point, we have 2 reactions, since again that is a hinge. And this one is internal hinged. So we have here 2 internal forces, the same as with the other side. Again, this one is symmetrical. Okay, so we have a rightward force and a downward force. And on the left, or on the right end or right hinge, we have here, still we have 2 external reactions or forces. So total, we have number of reactions. We have 4 reactions. Okay, from the formula R plus Fi, then 3 and R. So we have 4 reactions plus the internal force, since we have 1 internal hinge, so that means we have 2 internal forces. We have 2. Then 3 times the number of rigid body here, or rigid member. We have this counts as 1, and this counts as 1 as well. So overall, we have 2 rigid members. Okay, so we have 4 plus 2, we have 6, and this one is 6. So that means we have equal sign. So we can say then that this one is a statically determinate externally. So we can use the equilibrium equations in computing the unknowns. Okay, and that ends these lessons about the determinacy and stability of structure. Thank you guys, but please don't forget to subscribe to my channel and hit the notification bell for more videos. Thank you guys and God bless.